Welcome to Induction Technique Part 1. Let's begin by explaining what induction heating is. Induction heating is a contactless heating method of bodies which absorb energy from an alternating magnetic field generated by an induction coil or inductor. There are two mechanisms of energy absorption: generation of closed-loop or eddy currents inside the body, which cause heating due to electrical resistance of the body material, and hysteresis heating for magnetic materials only, due to a friction of magnetic microvolumes, domains, which rotate following orientation of external magnetic field. Eddy current heating occurs in all conductive materials, magnetic or non-magnetic steels, copper, aluminum, graphite, molten glass or oxide, and more, when they are placed in an alternating magnetic field. Eddy currents always flow in a closed loop, which is a law of nature, and for effective heating, there must be a good path for current to flow into the part to be heated. For example, it is easy to heat a wire loop, but almost impossible to heat a thin wire when the loop is open. Hysteresis heating is zero in non-magnetic materials, such as aluminum, copper, and hot steels, or responsible for a small percentage of heat generation in compact magnetic bodies, mainly steels at low or middle temperatures. However, in magnetic materials composed of particulates, including magnetic flux concentrators, hysteresis may be the major source of heat generation. Each particle is heated individually, and the workpiece may have any shape and size, such as massive bodies, strips, films, and wires. The chain of phenomena begins when the power supply delivers current, I1, to the induction coil. Coil currents, ampere turns, generate magnetic field. Lines of field are always closed by law of nature, and each line goes around the current source, coil turns, and workpiece. Alternating magnetic field flowing through the part cross-section, coupled to the part, induces voltage in the part. Induced voltage creates eddy currents, I2, in the part, flowing in a direction opposite to the coil current where possible. Eddy currents generate heat in the part. There are three closed loops in any induction device: coil current, I1 loop; magnetic flux, phi loop; eddy current, I2 loop. Magnetic flux loop may be materialized as a magnetic core in a transformer-type induction system, shown right, or be invisible, such as in air or other surrounding media. Magnetic flux loop is very important because that is where we can install a magnetic flux controller to improve heating.